Hello everyone. Welcome to our virtual review on licensure examination for teachers, specifically in general mathematics. I am Julius Espadero, your lecturer. Okay, so the first thing you should know is to determine the coverage of the examination. It is very important to determine what topic or concept you should study in order to save time and effort. So in general education, we have English, Filipino, mathematics, science, and social sciences. Okay. But in mathematics, we have fundamentals of math, plane geometry, elementary algebra, basic probability, and statistics. Okay, so let us start with the fundamentals of mathematics. Okay, so we are going to start with the integers and its operations. The first one is addition of integers. How do we add integers? When the integers have like or same signs, add the absolute values of the numbers and affix the common sign. So in this particular example, we want to add negative 79 and negative 168. Since both are negative, then we are going to add the two numbers. So 79 plus 168 is 247. But since the two numbers are both negative, so we copy the common sign negative. So the final answer should be negative 247. How about this one? Negative 75 plus negative 53 plus negative 69. All numbers are negative, so therefore we are going to add the three numbers. So 75 plus 53 plus 69 will give us 197. But both numbers are negative. So therefore, we are going to copy the sign of the three numbers, which is negative. So the final answer is negative 197. Okay, how about if we are going to add integers with different signs? So when the integers have unlike or different signs, get the difference of their absolute values, then affix the sign of the number with a greater absolute value. For example, you are given negative 259 plus 381. In this case, the two numbers are different or have different signs. One is negative and the other one is positive. So we expect that the two numbers will be subtracted. So 381 minus 259 will give us 122. But please remember that 381 is larger than 259. Okay, so 381 is larger or greater than 259. So therefore, we are going to copy the sign of 381, which is positive. So the final answer is positive 122. Example letter B, 97 plus negative 151. The two numbers have different signs, so we are going to subtract 151 by 97. So 151 minus 97 will give you 54. But 151 is larger than 97, or the absolute value of 151 is larger than the absolute value of 97. So therefore, we are going to copy the sign of 151, which is negative. Try to practice. What is the sum of 124 and negative 225? A, 101, B, negative 101, C, 349, letter D, negative 349. Timer starts now. Okay, so the correct answer is letter B, negative 101. In this case, we are given two numbers with different signs, so we are going to subtract 225 by 124. So 225 minus 124 is 101, but since 225 is larger than 124, so we copy the sign of 225, which is negative. So therefore, the final answer is negative 101. Okay, next example. What is the sum of 13 plus negative 25 plus negative 42? Timer starts now. Time is up. So the correct answer here is letter C, negative 54. So we have here 13 plus negative 25. Since the two numbers are different or have different signs, so we're going to subtract 25 by 13, and it will give us 12. But since 25 is larger than 13, we copy the sign of the larger number. Then after that, we are going to add negative 42. So negative 12 plus negative 42 will give us 54. But since the two numbers have the same sign, so we copy the common sign, which is negative. So the final answer is negative 54. Now let us try to proceed to subtraction of integers. How do we subtract integers? We are going to change the sign of the number being subtracted, and then we are going to proceed to addition. For example, suppose you are given 54 minus negative 120. So we are going to change the sign here of negative 120, or this is the number being subtracted, and then we proceed to addition. That means 54 minus negative 120 is now 54 plus 120. And 54 plus 120 is 174. Example letter B. You are given negative 65 minus 89. So we are going to change the sign of the number being subtracted. So we are given negative 65 plus negative 89. So the two numbers have the same sign, which is negative. So we are going to add the two numbers. 65 plus 89 is 154, but the two numbers are both negative, so we copy the sign of the two numbers, which is negative. So the final answer is negative 154. So this is the example. Find the difference of negative 52 minus negative 58. Timer starts now. Okay, time. The correct answer is letter C. So in this case, you are given negative 52 minus negative 58. So we need to change the sign of the number being subtracted. So we have now negative 52 plus 58. They have now different signs, so we subtract 58 minus 52 is 6, but the bigger number is 58, so we copy the sign of 58, which is positive. So therefore, the answer is positive 6. Okay, so here is another example. Find the difference of 12 minus negative 22 minus 38. Timer starts now. Time is up. So the correct answer is letter D, negative 4. So in this case, we are going to change the sign of the number being subtracted here. So from negative 22 it became positive 22. So we're given 12 plus 22 minus 38. And then 12 plus 22 is 34. And then minus 38. And if you notice, 38 is larger than 34 and they have different signs. So we are going to subtract. So we are given 4. But 38 is larger than 34. So it should be negative 4. We proceed now to multiplication and division of integers. In multiplying and dividing integers, you multiply or you divide the absolute values of the integers. If the integers have the same sign, the product or quotient is positive. If the integers have different signs, the product or the quotient is negative. So for example, find the product of negative 15 and negative 5. Since the two numbers are both negative, we expect the answer is positive. So we have only two choices with positive sign, letter A and letter C. So you are going to eliminate now letter B and letter D. But of course, if you are going to multiply 15 and 5, the correct answer is 75. So therefore, the answer is positive 75. So letter A. Let us try another example. So we want to find the product of negative 5, negative 7, and negative 2. You may think that the answer is positive because all the numbers are negative. But we are going to multiply the numbers by pair. So therefore, negative 5 times negative 7 will give you positive 35. And then later on, multiply it by negative 2. Now this time, 35 and negative 2 have different signs. So we expect that the answer should be a negative number. Okay? So therefore, 35 times negative 2 will give you negative 70. Now for the division, find the quotient of negative 87 and 29, or negative 87 divided by 29. The two numbers are or have different signs, so expected natin ang sign ay negative. So either B or C ang ating pagpipilian. But 87 divided by 29 is 3. So in other words, you are given negative 3, or letter B is the final answer. Another example, find the quotient of negative 48 divided by 6 divided by negative 4. Now here, you are going to use the left to right process. Okay, meaning you are going to divide from left going to the right. So and besides, this particular symbol is a grouping symbol. So we need to divide first the terms or the numbers inside the parentheses or the grouping symbol or symbol. So what is negative 48 divided by negative or positive 6? That would be negative 8 because they have different signs. Then after that, you divide negative 8 by negative 4. This time they have the same sign, so we expect the answer is positive. We know 8 divided by 4 is 2. So the final answer is letter A. Okay, so next topic is all about basic divisibility rule. The first one is divisibility by 2. A number is divisible by 2 if and only if the units digit is divisible by 2. For example, Are the following numbers divisible by 2? Letter A, 453,758. Since this number ends with 8, which is an even number, or 8 is divisible by 2, then the whole number, which is 453,758, is also divisible by 2. While in letter B, this is 3,449, 9 is not divisible by 2. So therefore, the whole number is not divisible by 2. So here, say yes. Here, no. Try to consider divisibility by 3. A number is divisible by 3 if and only if the sum of its digits is divisible by 3. So for example, is 285,327 divisible by 3? So let's check. If you are going to add the digits of the number 2 plus 8 plus 5 plus 3 plus 2 plus 7, the sum is 27. Now 27 is obviously divisible by 3. So therefore, the whole number 285,327 is divisible by 3. So the answer is yes. Next is divisibility by 4. A number is divisible by 4 if and only if the number represented by its tens and ones digit or digits is divisible by 4. For example, is 2,332 divisible by 4? We are going to check the last two digits. In this case, we have 32. Is 32 divisible by 4? Since 32 is divisible by 4, then the whole number 2,332 is also divisible by 4. Okay, so next is divisibility by 5. This is easy one because a number is divisible by 5 if and only if the units digit is 5 or 0. So the question, are the following numbers divisible by 5? So letter A, the number 285,325 ends with 5 and 563,680 ends with 0. So these two numbers are both divisible by 5. So the answer is yes. Okay, divisibility by 6. If the number is divisible by 2 and 3, it is also divisible by 6. So for example, is 15,204 divisible by 6? So the last digit is 4, which is divisible by 2. So check na ito. Then, if you are going to add the digits of the number, which is 1 plus 5 plus 2 plus 4, or plus 0 plus 4, the answer is 12. And 12 is divisible by 3. So divisible by 2 and divisible by 3, therefore divisible by 6. Okay, so here is the application of the basic divisibility rule. What is the value of k for which the number 3, 4, k2 is divisible by 6? Timer starts now. Okay, time is up. The correct answer is letter C. Now, in order for us to determine if the number is divisible by 6, it should be divisible by 2 and at the same time divisible by 3. This number is obviously divisible by 2. So, ang i-check na lang natin kung ito po ay divisible by 3. So, in order for us to have a number which is divisible by 3, we are going to add all the digits. So, 3 plus 4 plus k plus 2. And we know 3 plus 4 plus 2 is 9 plus k. So, ano kaya itong k na yan? If we are going to substitute the choices to the variable k, so for example, 9 plus 1, because a is 1, we are given 10. And 10 is not divisible by 3. So, wala na itong letter A. However, if you are going to substitute the value of k or the value 2 to k, you are given 9 plus 2 is 11. 11 is not divisible by 2. But for letter C, 9 plus 9 is 18. And 18 is obviously divisible by 3. So therefore, this must be the value of k. So the answer is letter C. Let's try another example. Which of the following is not divisible by 4? Timer starts now. Okay, so time is up. So the correct answer here is letter C. So we are going to find which of the following is not divisible by 4. So obviously here, for letter A, 16 is divisible by 4. Then the whole number is divisible by 4. Then 8 is divisible by 4. So the number 1808 is divisible by 4. 12 is divisible by 4. So the whole number is divisible by 4. So the answer here is letter C, because 49 is not divisible by 4. So the whole number 1349 is not divisible by 4. Okay, so next topic is all about prime and composite numbers. What is the difference between prime number and composite number? If you are going to define prime number, if a counting number has 1 in itself as its only factors, then the counting number is called a prime number. Whereas if a counting number has factors other than 1 in itself, then the counting number is called a composite number. So for example, in the prime number, we can say 3 is a prime number because the factors of 3 is 3 and 1, or meaning 1 and itself. Okay? No other factors or factor. Another example is, say, 5, because 5 is 1 times 5. No other factors. Whereas, for the composite number, suppose you are given 6, we know 6 is 1 times 6, 2 times 3. So if you notice, there are more than 2 factors. 1, 2, 3, and 6. So that's it. That's the difference between prime number and composite number. Of course, it is very important to study or to know the difference between prime number and composite number, because sometimes you will be given a problem like this. Which of the following numbers does not belong to the group? A 27, B 56, C 53, letter D 80. In this problem, the correct answer is Letter C, because all numbers are composite except 53. So for letter A, 27 can be 1 times 27, can be 3 times 9. Okay, 56 can be, 56 is divisible by 2. Okay, and 80 is divisible by 2, by 5, by 10, by 4. So definitely A, B, and D are all composite numbers. But 53 is just 53 times 1. So no other factors or factor other than 1 and itself. Okay, so here is another problem involving prime and composite number or numbers. How many prime numbers are there from 1 to 20? You may pause this video and try to answer the problem and then play it again in order for you to check if your answer is correct. Okay, so you may do it now. Okay, so the correct answer in this problem is letter C. What are those prime numbers from 1 to 20? So we are given 2, 3, 5, 7, 11, 13, 17, and 19. So there are 8 prime numbers from 1 to 20. Please take note we did not include 1. Okay? Because 1 is neither composite nor prime number. Okay, we know 1 is just equal to 1 times 1. So there is only one factor. This violates the definition of prime numbers. Okay, so next topic is all about the greatest common factor or the GCF. Okay, so your knowledge of prime numbers, divisibility rule can be applied in this particular topic. So what is the greatest common factor? The greatest common factor of 2 or more integers is the largest integer that is a factor of both or all numbers. Alright, so let us try to consider this example. What is the greatest common factor of 72 and 80? So what we are going to do is to use the idea of prime factorization. Okay, so we have the prime factorization. Okay, so in prime factorization, the prime factors of 72 is 2 times 2 times 2 times 3 times 3. And 80 is 2 times 2 times 2 times 2 times 5. The numbers 72 and 80 have common factors, which is 2. And then you just multiply them to get the greatest common factor. So 2 times 2 times 2 equals 8. So therefore, the greatest common factor of 72 and 80 must be 8. Okay? By the way, in order to have the prime factorization, you can use the factor 3. Meaning, you can say 72 is divisible by 2, so 2 times 36. And 36 can be divisible by, can be divided by 2. So 36 divided by 2 is 18. And 18 is divisible by 2, so 18 divided by 2 is 9. And 9 is divisible by 3, so 3 times 3. So you're given 2 times 2 times 2 times 3 times 3. So that is the process of prime factorization. You can use the factor 3. Next problem. What is the greatest common factor of 45, 81, and 90? So the same process, we need to use the prime factorization of 45, 81, and 90. So here the answer is letter B. So 45 can be equal to 3 times 3 times 5. 81 can be 3 times 3 times 3 times 3. 90 can be equivalent to 3 times 3 times 2 times 5. And we have common factors, 3. So to find the greatest common factor, just multiply the common factors. So 3 times 3 is equal to 9. That's the answer. Okay, so let us try to consider now the next topic, which is the least common multiple, or the LCM. What is the least common multiple? The least common multiple is simply the smallest of the common multiples. So for example, we want to find the least common multiple of 3 and 5. So 3 can be listed as 3, 6, 9, 12, 15, and so on. For the 5, we have 5, 10, 15, 20, 25, and so on. Now if you notice, the blue numbers, 15, 30, 45, those are common multiples. Okay, so 15, 30, and 45. And marami pa yan. So infinite yan. But the question is, what is the smallest or the least common multiple for 3 and 5? So the correct answer is 15 in this case. Now let us try to have a sample problem. What is the least common multiple of 15 and 27? So the correct answer here is 135, but how did we get 135? So the same process, you use the prime factorization. So 15 can be 3 times 5, 27 is 3 times 3 times 3. But if you notice, we have the common factor, which is 3, or the greatest common factor, which is 3. And then the remaining will be multiplied to the greatest common factor in order to get the least common multiple. So here, this is the greatest common factor, and then the rest will be multiplied. So 3 times 5 times 3 times 3 will give you 135. So what is the meaning of this? In other words, 135 can be divided by 15, and at the same time can be divided by 27 without the remainder. And 135 is the least common multiple. Meaning if you list 15, 30, what's the next for 30? We're given 45 and so on. So you are given 135 as the least common multiple here. If you are going to list also 27, so 54 and so on, we have 135. So if you are going to list down all the numbers, we have 135 as the least common multiple. Kaya lang mahirap kapag tayo ay maglilista. Okay, so that's why it's easy to use this method, okay, the prime factorization and finding the LCM. Okay, so let us try another problem. What is the least common multiple of 72 and 80? Timer starts now. Okay, so time is up. The correct answer is 720. So the same process, we use the idea of prime factorization. So the factors of 72 is 2 times 2 times 2 times 3 times 3. The prime factors of 80 is 2 times 2 times 2 times 2 times 5. Then we get the greatest common factor, or the common factors, which are 2 times 2 times 2. And then you multiplied it to the remaining prime factors of 72 and 80. So the LCM is, or the LCD, so you are given 2 times 2 times 2 times 2, which is the GCF, or the greatest common factor. And then here 3 times 3 times 2 times 5. So if you multiply those numbers, the resulting number is 720. Okay, next problem is, what is the least common multiple factor of 45, 81, and 90? Timer starts now. Time is up. The correct answer for this problem is letter A. Okay? So the same process, we are going to get the prime factorization of 45, 81, and 90. So 45 is equal to 3 times 3 times 5. 81 is 3 times 3 times 3 times 3. 90 equals 3 times 3 times 2 times 5. So we get the common factors. So you are given 3 times 3. And then the common factor of 45 and 90. So that will be written as 1. So you are given 3 times 3 times 5. Ito yon. Times 3 times 3 and times 2. And if you are going to multiply those numbers, the product will give us 810. Thank you very much for watching and listening, and I hope you learned something from this video. I will leave you a saying from Andre: if you don't practice, you don't deserve to win. So please click the link at the description below to download the practice activity. Thank you.